Hello, everyone. For today's lecture, I'm going to talk about the DJ cycle analysis. Okay, so for today's lecture, I'm not going to use a whiteboard because using slides and lecture notes will serve better about the contents of today's lecture. So please read chapter 9.6 of your textbook to understand better about the DJ cycle. And at the end of today's lecture, I really hope that you can answer these two questions. The first question is, how can we calculate each state of the DJ cycle? And second question is, how can we conduct the thermodynamic analysis of the DJ cycle, particularly about the power output or work output and the thermal efficiency? Let's briefly review what we learned in the last lecture. So in the last lecture, we learned about the ideal Otto cycle analysis. And I hope that you should be able to draw the PV diagram and TS diagram for the ideal Otto cycle. And now, as you look at this diagram, we have the isentropic compression and constant volume heat addition and isentropic expansion and constant volume heat rejection process. Okay? And there is a heat input during the process 2 to 3 and heat rejection, heat out from process 4 to 1. And net work can be graphically represented by the area surrounded by these four processes. Okay? So from the first law of thermodynamics, we can calculate net amount of work in terms of Q in minus Q out. Okay? Or net amount work can be calculated by expansion work, that is during the process 3 to 4, minus compression work, that is from process 1 to 2. We also can draw the TS diagram for the ideal Otto cycle, as you see on the right side. Okay? And that is what we have. So now, after we calculate the net work, then we also can calculate thermal efficiency, which is defined as W net divided by Q in. That is what we learned in the last lecture. Okay, then let's try to see four-stroke diesel engine. Even though in the United States we mostly use the spark ignition engine or gasoline engine for passenger cars or small cars, in many European countries and Asian countries, they use diesel engines quite a lot as well. Okay? So one example is the BMW car, and BMW is a quite active manufacturer of diesel engine cars, and they also have pretty good diesel engine, as you see on the right-hand side, and they are so proud of this engine. Okay? And then what is different between the diesel engine and the gasoline engine? Okay? So let's try to look at the process, so strokes. So now still we have 4 strokes to make one cycle, even for diesel engine. And now intake process looks pretty similar. Okay? Compression, yeah, that's almost same. Just process is also quite similar. Okay? But there are 2 big differences. The first big difference of the diesel engine compared to gasoline engine is that for gasoline engine, it intakes a fuel and air mixture. So fuel and air is already mixed outside the engine, and they just are brought into the cylinder. Okay, but for diesel engine, only the fresh air comes to the engine, okay, during the intake stroke. And now fresh air is compressed. Then at the end of the compression, we have a fuel injector in the engine. So we don't have a spark plug for diesel engine, but instead we have a fuel injector. And through the fuel injector, fuel is sprayed out to highly pressurized air, and that is well mixed, and that induces certain auto or kind of self-ignition process. Okay, then we have exhaust process, exhaust stroke at the end. Then this table compares the SI engine and CI engine in more detail. So as I explained a little bit briefly in the last slide, the SI engine has a pre-mixed fuel and air mixture coming to the cylinder. Okay, but CI engine or diesel engine has only the pure air drawn into a cylinder, and at the end of compression, then fuel is injected into the cylinder just before combustion. And why is that? Because the SI engine has spark plug, and this spark plug ignites the flame, and this flame propagates to make a combustion process. However, in the CI engine, we don't have any spark plug, but instead, because already the air is highly pressurized, which means at high temperature, and that is already higher than the spontaneous ignition temperature. So as soon as fuel is injected, there is a flame auto-ignited in everywhere to make a combustion process. Now, how power is controlled in the SI engine? The power is controlled or reduced by throttling the air-fuel mixture in the SI engine. But in the CI engine, power is controlled by controlling the amount of fuel injection. Okay, so there's difference. The fuel of the SI engine is usually gasoline. Okay, gasoline is very light and volatile fuel. Okay, so by having the spark plug, that can be easily ignited. And compared to that, CI engine has a fuel, a diesel as a fuel, and that is quite heavy fuel, and that is quite big difference in terms of fuels. Now, SI engine usually has a lower compression rate, around 10, and maximum around 11. And theoretically speaking, the SI engine also can be better for higher compression ratio, but the knocking condition severely limits the compression ratio for the spark ignition engine. Compared to that, CI engine can have much higher compression ratio because diesel is not ignited quite easily as gasoline. So it can endure to the much higher compression ratio. And basically, we use this kind of type of induced or spontaneous compression ignition. So that's quite desired portion. Okay, so that's why we have much higher compression ratio. That's many times why CI engine outperforms the SI engine. Okay, we are going to talk about it later. Usually in the SI engine, we don't need a turbocharger. So what is a turbocharger? So turbocharger is a component that squeezes more air into the cylinder by putting already pressurized air to the engine. For gasoline engine, we don't need that much because we already mix the air with the fuel, and basically it's just has just more expensive, but it doesn't give us that much of benefit. Only very high-end cars have this type of turbochargers, and yeah, it's kind of sporty unit in the many model lines. About compression ignition engine, it usually have turbocharger because we need to put more air into the cylinder to boost up the power. Okay, so that is why CI engine usually has a turbocharger. Now, let's try to compare what really happens, by looking at these video clips. Okay, again, the left-hand side is about SI engine. Okay, now I'm going to show you this video clip of how this piston up and down during the stroke and how flame propagates during the combustion process. And now, as you see, here is a spark plug at around the corner, and in the middle we have a valve, and that is piston, and piston goes down and up, during the intake, stroke, compression, combustion, expansion, and exhaust. Okay, and let me click this video. That is the intake process. So now we have air and fuel mixture coming in. Okay, the valve closes. Then piston should go up. Yes, piston moves up. And now at the end of compression, spark flame propagates from this point all the way to the cylinder. And now we have expansion, and now we have exhaust stroke where the valve is open. That is how spark ignition engine runs. Okay. I'm going to upload these video clips to Canvas such that you can take a look at it again. And how about CI engine? So, as I explained in the previous slide, CI engine doesn't have a spark plug, but instead it does have a fuel injector. So you are going to watch, fuel is injected to the cylinder a couple of times during the compression process. And you can see how flame propagates throughout the sprayed direction of the fuel. And let's take a look. And now you see the piston kind of comes up. So that is the end of piston. Now we have sprayed fuels. Now at a certain, yes, now we have flame starts. Yeah, so around following the sprayed direction of fuels. And that is how, and you see also swirling or like rotating of the flame, okay, around the cylinder combustion, space. That is how we see it. Now we can measure the pressure and volume from the real diesel engine, and that is what we see of that measure, the change of pressure and volume during this the stroke of the diesel cycle or the diesel engine. And now we have intake stroke, and at the end of the intake stroke, now we have compression stroke, all the way will go up. Now we have conversion process. Now then we see biggest difference here. Okay. Now, when you recall what we see in terms of PV diagram of the real gasoline engine, we have for the real gasoline engine we have a spark plug, and this spark plug helps the combustion process so quickly. So the combustion process essentially happens at the constant volume process. But in a real diesel engine, your air and fuel mixture is auto-ignited. That means that it does need a certain more time to complete the combustion process. Okay? So as you see here, during the combustion process, pressure maintains almost at the same value while we have more expansion involved of the volume, okay? Because there needs certain more time to complete the combustion process in the compression ignition engine. Then we have expansion, and the exhaust valve is opened. Then we have exhaust process or exhaust stroke here. So that is how we see the real P pressure and volume changes in a real diesel engine.